Hi guys, how are you? I hope you and your family are doing well. So let's continue with the binomial probabilities. So let's do a couple of examples first. First example, let's say so a family wants to have 6 children. So wants to have six children. Okay, and let's assume that the probability, so assuming that, so the probability that, so assuming that the probability of a child being a girl, of a child being a girl is 60%. Okay, is 60%. Well, so let's find the probability that the family has exactly, let's say, 4 girls. So find the probability that the family has exactly 4 girls. Okay. Well, so this is a binomial. This is a binomial experiment because a child, is either a girl or a boy. Okay, so either. So there are 2 possible outcomes, right? The child is either a girl or a boy, right? So this is the binomial experiment because, okay, so this is a binomial experiment because a child is either a girl, so that's a success, okay, or a boy, so having a boy would be a failure. Okay, so this is a binomial experiment because there are 2 possible outcomes, right? The child being a girl, okay, so that will be a success, or a boy, and that will be a failure. Okay. Now, what's the probability of success here? Well, so we said the success here. Success is the child is a girl, right? So the success is the child is a girl. Is a girl. Right. Now, what's the probability of success? Probability of capital S, success. So that's a probability that the child being a girl. So being a girl, that's a 60%, right? So 60%, or if you want, this is 0.6. Now, what's the probability of failure? So probability of failure, Q, that's of course, we said so there are 2 possible outcomes. Either the child is a girl or a boy. So having a boy would be a failure, right? And that would be, of course, 40%, right? Because the 2 probabilities, they add up to 1, right? So that's 0.4, right? So remember, P plus Q, they must be equal to 1, right? So they must add up to 1, right? Now, we want to find the probability that the family has exactly 4 girls, right? So remember, guys, here R, that's the number of successes. And the success here is that the child being a girl, right? So here we want to find the probability that the family has exactly 4 girls. So the number of successes here is 4. And what's the number of trials? Well, here the family wants to have 6 children, right? So the number of trials is actually equal to 6. So N is equal to 6. Okay, so now let me just remind you our formula. So P of R is supposed to be equal to N, choose R, okay, P to the power R times Q to the power N minus R, okay. So the probability that the family has exactly 4 girls, so R is 4, N is 6, again because the family wants to have 6 children. Probability of success with the child being a girl is 60%, so that's P is 0.6 and Q is 0.4. So we have N, so that's 6, choose R is 4, exactly 4. 4 successes, right? So 6 choose 4 times P, probability of success, that's 0.6 to the power R is equal to 4 times, right? Here this is P, that's 0.6 to the power 4. Q, that's 0.4, right? This Q here, that's 0.4 to the power N, which is 6, minus R, so minus 4. Okay, so P of R equal to 4. So we said that's 6 choose 4, so that's remember the formula for 6 choose 4, so that's 6 factorial over 4 factorial times 6 minus 4 factorial, right? Times 0.6 to the power 4 times 0.4 to the power, so 6 minus 4, that's square, so that's power 2. Okay, so this probability that the family has exactly 4 girls, R is equal to 4, so we have 6 factorial. Remember 6 factorial, that would be 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial. That's 4 times 3 times 2 times 1 times, and then 6 minus 4, that's 2 factorial, and so 2 factorial, that's 2 times 1, all right? Times, so 0.6 to the power 4, that's actually equal to 0, so times 0.1296 times, and then 0.4 square, that's 0.16. Okay. Now, so here we can cancel out here. This is 1, 2, 3, 4, right? And then there's 6 over 2, that would be 3, right? So we're gonna have in the top, that would be 3 times 5, that's 15. So this probability that the family has exactly 4 GERs, it's going to be equal 30 times 5 over 1, so that's 15 times 0.1296 times 0.16. So that will be equal to 0.31104, and in percentage, that will be 31.104%. So it's approximately 31%. Okay. Now next, let's say you want to find the probability that the family has at least 4 GERs. So the probability, so let's find the probability that the family has at least 4 GERs. Okay, so here at least it means that the minimum number of GERs here would be 4. So the number of successes here would be at least 4. So R, okay, again, that's the R, that's the number of successes, that's the number of GERs, right? Number of successes, that's the number of GERs. So it's at least 4. It means it's either 4, 5, or 6. So 4 or 5 or 6. Okay, so the minimum number of GERs here is at least, so it's at least 4. So the minimum number of GERs is 4. So it will be 4 or 5 or 6, because of course the family wants to have 6 children. Okay, so the maximum would be 6. Okay, so we want to compute the probability that R is 4, or R is 5, or R is equal to 6. Okay, now because of OR, so we're going to have, so this OR here, so we're going to have addition here, right? So that will be probability that R is equal to 4 plus, okay, plus it's because of the OR, plus probability that R is equal to 5, and then there's another OR, right? So there will be another plus, so plus probability that R is equal to 6. Okay. Now, so let me write it again. So R is equal to 4 or 5 or 6. So we said that's P of R equal to 4 plus P of R equal to 5 plus P of R is equal to 6. So P of R, number of successes is equal to 4, or number of GERs is exactly 4. So we already computed this in the first question. So that's we said that's equal to 0.31104, right? So that's 0.31104. Okay, again, this is the probability that R is equal to 4 plus, now probability that R is equal exactly to 5, right? So R is 5. So we have, again, the number of trials is 6. So that's 6. Choose 5, right? Times the probability of success, which is 0.6, having a GER, that's 0.6 to the power R, so to the power 5, times probability of a failure, that's 0.4 to the power n minus r. N is 6 minus 5, so 6 minus 5 is 1. Okay, so again here, this is the probability that r is equal to 5. Okay, and then plus probability that r is equal to 6. So that's n, choose r, so that's 6, choose 6, because my r is 6, times probability of success, that's 0.6, having a GER, to the power r is 6, so the power 6, times the failure q, which is 0.4, to the power n minus r, so that's 6 minus 6, that's 0, power 0. Okay, so this is the probability that r is equal to 6. So that will be equal to, so we have this 0.31104 plus, so this 6, choose 5, so that's 6 factorial over 5 factorial times 6 minus 5 factorial, that's 1 factorial, so this is 1 factorial, 0.6 to the power 5, that's, so times 0.6 to the power 5, that's actually 0.07776 times 0.4 to the power 1, that's just 0.4, so times 0.4 plus, and then we have 6, choose 6, so that's 6 factorial over r factorial, so r is 6, so that's 6 factorial, over n minus r factorial, so that's 6 minus 6, so that's 0 factorial here, and then 0.6 to the power 6, so that's times 0.046, okay, and then times 0.4 to the power 0, that's any number, any non-zero number, power 0 is just 1, so that's times 1, okay. So now that will be equal to 0.31104 plus the 6 factorial over 5 factorial. So that will be equal to 6 over 1, so that's actually 6, so this is 6 times this 0.77, so that's 0.07776 times 0.4 plus 6 factorial. So 0 factorial, this is actually equal to 1, right? 6 factorial over 6 factorial, so it cancel out, it's just 1, so that's plus. So that will be 1 there, so it's 1 times 0.046 times 1, okay? So that will be equal to 0.31104 plus the 6 times 0.077, etc. times 0.4. That's actually 0.186624. And then we have this 0.046. Okay, and final answer will be approximately 0.544. Okay, so this is, this is for 54%. Okay, so that's the final answer. Okay, guys, let's have one more example. Again, if you have any question about these examples, just email me. Example number 2. Okay, example number 2. Well, this example number 2, so the example number 2 says the following. So in 2019, approximately 80% of students taking online classes were enrolled part-time. Okay, so 80% of students taking online classes they were enrolled part-time. Okay, were enrolled part-time. Now, suppose we randomly select, let's say, 5 students taking classes online. Suppose we randomly, of course, select 5 students taking classes online. Classes online. So what's the probability okay, classes online. So what's the probability that exactly 3 of those students are enrolled part-time? So what's the probability? So find the probability that exactly 3 of those students, exactly 3 of those students are enrolled part-time. Are enrolled part-time. Okay. Well, why this is first? So why this is a binomial experiment? Well, because when you select a student, right? When you select randomly a student, so either the student is, of course, enrolled part-time or full-time, right? So there are only two possible outcomes here. Either a student is part-time or full-time. So the success here would be a part-time, and the failure would be that the student is not part-time. Let's say the student is a full-time. So this is a binomial experiment. Because, so there are two possible outcomes. The selected student is either, so it's a part-time, is either part-time student, so that will be a success. So that will be my success, capital S, or not part-time, let's say full-time, so full-time, and that will be a failure. Okay, now what's the probability of success? P. So what's the probability that the student, again, the success here is that the student is a part-time student, right? So probability of success here, we know that 80% of students taking online classes are enrolled part-time, right? So probability of success is 80%. Again, the success is that the student is taking online classes is a part-time, okay? So the success here, probability of success is 80%, that's 0.8. And probability of failure, Q. Remember, guys, P plus Q, they are equal. P plus Q is always equal to 1, right? They add up to 1, so that's 20%. So that's 0.2. Okay. Again, that's because P plus Q is always equal to 1. So 0.8 plus 0.2 is equal to 1. Okay. Now, what's the number of trials here? Well, we selected randomly 5 students, right? So the number of trials, that's the number of students that's equal to 5. Okay. Now, what's the number of successes here? So we are looking for the probability that exactly 3 of those students are enrolled part-time, right? So again, success here would be that the student is a part-time. So the number of successes here R is equal to 3, right? So now we're going to compute probability of R is equal to 3. Again, that means that that's the probability that exactly 3 of those students are enrolled part-time, right? So 3 out of 5 are enrolled part-time. Okay. So that will be equal. So we apply our formula. So we have n choose R. So n is 5. Choose R. R is 3. Number of successes here is 3. Again, that's number of successes. Okay. Times, well, P, that's probability of success. So that's P to the R. So P is probability of success. That's the 80%. That's the 0.8. So this is 0.8 to the power R. So power 3 times Q, probability of failure. So that when the student is not part-time, when the student is full-time, let's say, that's 0.2 to the power n minus R. N is 5, R is 3. So that's 5 minus 3. Okay. So 5 choose R. 5 choose 3, that's 5 factorial over R factorial, so that's 3 factorial times 5 minus 3 factorial times, so 0.8 cube, that would be 0.512 times 0.2 to the power 5 minus 2, that's a square, okay? So that will be equal to, so 5 factorial, that's 5 times 4 times 3 times 2 times 1 over 3 factorial, that's 3 times 2 times 1 times 5 minus 3. This is, of course, 2. So that's 2 factorial, so that's 2 times 1. So times, so 0.512 times the 0.2 square, that's 0.04. Okay, so that'll be equal to, so let's, so here, 1 here cancel out, of course, 2 cancel out, 3 cancel out, and then we have 4 over 2, that would be 2, so that's actually 5 times 2, that would be 10, so 10 times 0.512 times 0.04, and so that will be equal to 0.2048, or that's actually 20%, 0.48. So 20%, so 20%, 0.48, 20%, that's actually the probability that exactly 3 out of the 5 students are enrolled part-time. Okay. Now let's just finish with the mean and the standard deviation. Of binomial distribution or binomial probabilities. Okay. So the mean is, so we have the formula. So the mean, the average, let's say mu is always equal to n times p. Okay, and the standard deviation, sigma, that's always equal to square root of n times p times q. Okay. So for example, let's come back to this example with the students taking online classes. So we said 80%. So example number 2. So we have this, again, example number 2. Let me remind you of example number 2. So we have that approximately 80% of students taking online classes were enrolled part-time. Okay, part-time. So we said we selected actually 5. We selected we randomly selected the 5 students. Okay, so we said a number of trials was 5. Okay. So in this example, what would be probability of success? Again, that's P, probability of success. So the success here is that the student is enrolled part-time. So the probability of success is 0.8 again. And probability of failure, Q, that's, of course, 0.2. So that's 20%. Now, so if you want to compute the expected number of students that are enrolled part-time, the expected, so what's expected is, of course, that's the mean, the average, right? So the expected number of students out of the 5, of course, that are enrolled part-time. So we randomly selected 5 students, right? So number of trials is 5. So now what's the expected number of students that are enrolled out of this 5 students that are enrolled part-time? So that will be the mean. So that's equal to mu. We said that's n times p. So number of trials is 5. That's the number of students. P, probability of success, that's 0.8. So 5 times 0.8, that's 4. So what does it mean 4? It means that we expect that 4 out of the students that we selected are actually enrolled part-time. So we expect 4. So we expect that 4 out of the 5 students selected, randomly selected, are actually enrolled part-time. Okay. Now, what will be the standard deviation? Again, the standard deviation measures the spread, right? That's the spread, measures the spread about the mean. So that's square root of n times p times q, right? So that's square root of n, that's 5, times p, that's 0.8, times 0.q, failure. The student is full-time, that's a 0.2, right? So that would be equal to that's a square root of 0.8, right? 5 times 0.8 times 0.2, that's 0.8. Again, guys, PEMDAS rules, you have to do the, so you multiply 5 by 0.8 by 0.2, that's 0.8. So square root of 0.8, that's actually equal to 0.894. So that will be the standard deviation. Okay, guys, I guess I'm gonna stop here, and you're gonna find more details in the lecture notes, and I'm gonna probably post another video with more examples. So again, I will see you next time. Stay well and safe.